Okay, this is our chapter 9 unit of transformations. We're going to look at translations. First of all, some terminology. Original figure is your pre-image. It's also called your old figure, and your new figure is called the image. When a figure undergoes a transformation, the new figure is named using prime notation. So the example triangle ABC, when it goes, the transformation is now triangle A prime, B prime, C prime. Also, when you're drawing a picture, you know that it is the image if you have the dotted, if the figure is dotted. So this would be the image or new figure. Alright, so isometry, the transformation that doesn't change size of the figure, also known as a congruence transformation. A fancy way to say it is it preserves the length and the angle measure. Um, they have three types of isometries. We have translations, which we're doing today, reflections, and rotations. Um, an example of not something that's not an isometry is dilations. All right, so a translation, okay, which is also called a map. Every point of a figure is the same distance and the same direction. All right, so we have triangle RST. We have some coordinates for all the vertices. Find the image of the vertex after the translation, and here's your translation statement. XY turns into x plus 1 comma y plus 2. Okay, this x plus 1 comma y plus 2 is your rule. So when they're talking about a rule, that's what they're talking about. All right, so we're going to graph this image. So first thing I'm going to do is um, let's go ahead and get our points down. We can make a little chart real quick. Your pre-image and then your image. All right, so we have R being 2 comma 2. We have S being 5 comma 2, and we have T being 3 comma 5. All right, so applying the rule, we're going to add 1 to the x value. So R prime is now going to be 3, and we're going to add 2 to the y value, which will be 4. S prime will be 6, and then 4 for the y value, and then T prime will be 4 and then 7 for the y value. Then all we have to do is plot each coordinate. So R, we got 2, 2, that is R, 5, 2, S, and then T is 3, 5. Alright, so this is our original figure. We have it solid. Plot our other figure. 3, 1, 2, 3, 4. Right there. That's my R prime. S is 6, 4. S prime. And then T is 4, 7. I'll go ahead and dot it because this is the image or the new figure, and that is T prime. All right. Okay, now that's away. Alright, so the next part here is use the translation. So what is the image of a D which has the coordinates of 4, 7. So if that's the image, we are going to um, they if we're going to find the image, this D here is actually the pre-image. So the image is after we do apply the rule. So all we're going to do is D prime, because that would be the image, which would be 4 plus 2, which would be 6, and then 7 minus 5, which would be 2. Alright, same thing for 3, E prime would be negative 3 plus 2, which will be negative 1, and then 2 minus 5, which is negative 3, and that'll be those coordinates there. Now, what is the pre-image? And they give us the image with the prime in here. So since it's a pre-image, we'll have capital M with no prime. And we basically take this rule and do it backwards. Or opposite. That's probably a better word. Alright, so instead of x plus 2, we'll do x minus 2. Instead of y minus 5, we'll do y plus 5. So we subtract 2 from negative 5, that makes negative 7. And then if we add 5 to 3, that makes this 8. Alright, same thing here. Find the pre-image of n, and prime is the image, so regular n will be 9 minus 2, which is negative 11, and then 11 plus 5, which is negative 6. Alright, that's how you do that. So be sure you know what an image and a pre-image. A pre-image is the original figure, the image is the new figure. Okay, the image has the prime, the pre-image doesn't have the prime. Alright, so these ones here, we're just going to graph these on the triangle and then find the translation using the prime notation. So we have negative 2, 4. Alright, so negative 2, 4. And then we're going to apply this rule. So m prime here would be negative 2 plus 4, which would be positive 2. And 4 plus 2 would be positive 6. N prime, following this rule, will be negative 1 plus 4, which is 3. And y 1 plus 2, which would be 3. And then O prime will take 3 plus 4, which is 7. And then 3 plus 2, which is 5. Alright, plot those points. Remember, this graph here is going by 2's. So 2, 2, 4, and 6. Alright, that's m prime. N is 3, 3. So 2 and then half, and then 2 and then half. This would be n prime. And then O is 7, 2, 4, 6, and then halfway. And then 5, 2, 4, and then halfway. That is O prime. And that's a triangle there. Alright, we're just graphing the image, not the pre-image here. The pre-image, if you try to graph it, it's going to be off over here somewhere, so that wouldn't work. Alright, so number 7 has a different rule. We're going to subtract 5 from x and then subtract 6 from y. So taking the same coordinates, we're going to find the new m prime here. So negative 2 minus 5 is negative 7. And then 4 minus 6 is negative 2. N prime. Alright, so negative 1 minus 5 is negative 6. And then positive 1 minus 6 is negative 5. Alright, then we have O prime, which is 3 minus 5 is negative 2. And then 3 minus 6 is negative 3. Alright, so plot these points. Remember, again, the graph's going by 2's. Negative 2, 4, 6 and a half, then negative 2. Right there, that is m prime. 2, 4, 6, 2, 4, and then half. This would be n prime. And then O is negative 2, negative 3, 2, and then a half right there. O prime. Dotted lines. Oops, excuse me. And we have our figure as such. Alright, going to the next part. Alright, so now they want us to find a rule, x plus or minus something, comma, y plus or minus some number. And then they want us to verify it's an isometry. In other words, are we going to verify that the triangles are the same size? Alright, did it change size when the transformation happened? Okay, so first let's find the rule. So what we're going to do is you take one of the vertices. Let's go ahead and start with R, since it's right in the corner. So take the original R, and you want to trace it horizontally and then vertically to where it moved. So horizontally it moved 2, 4, 6, 8, 10 units, and then vertically it moved to 4, negative 4 units. So you want to remember a couple of things. Left is negative, right is positive, up is positive, down is negative. So remember that. Left and right are governed by the x-axis. Up and down is governed by the y-axis. Okay, so going back to this, our rule is basically going to be, since we went, and that should be negative 10. So since we went to the left, it's going to be x minus 10, comma, y minus 4, because we went down from the original position. So we went left and then down. So that's why the rule is going to have both negatives. So this is your rule right there. Now, to check if it's an isometry, there's two things we can do. Alright, so first thing you can do is distance formula. For every segment on there, or check your rule with every vertex. Alright, so if the rule doesn't apply, so we have three vertices here because it's a triangle. If the rule doesn't apply to any one of them, in other words, if you follow your rule from one point to the other and it doesn't match up, then it's not an isometry. Something has changed in the size of that shape, so that by definition makes it not isometric. So that's how you would do. So you would just see if this rule falls for area. So if you go T and you go 10 spaces over and then negative 4 down, 2, 4, 6, 8, 10, and then down 4, 2, and 4, and it matches up. Check S, 2, 4, 6, 8, 10, then down 4, 2, and 4, also matches up. So this one is isometric. Alright, so I'm not going to do vectors. Alright, so last one, just real quick to find the rule here. Okay, so just pick a point. Alright, so R needs to match over to this R and then up. So this one moves 2, 4, 5 units to the right. So that's a positive 5. Then it moves up 2 units. Every half is 1, so 1, 2. So this one moves over 2 units. So the rule for this one would be x plus 5, y plus 2. Alright, then check all the other points. 2, 4, 5, up 2. T matches up. 2, 4, 5, and then up 2. And S matches up. So this one is also isometric. Alright, and that's translations.